Hello and welcome to Coderific. In this video, you will learn how to visualize output filters from a trained model in Keras. Let's start programming. As you know, I always use Spyder that comes with Anaconda, and I love this Python editor. And I am back to it. And initially, I have already imported some imported libraries that I am going to use in this program, and out of which is Keras.models, and the model I am using from Keras.models, VGG16, and here to visualize the output filters, we are going to use the trained model of VGG16. I have also imported some other helping libraries that we will be using in this program. First, we need to load trained model of VGG16. Model is equal to VGG16 dot VGG16, and I am going to use pre-trained weights of ImageNet, and I am going to take the top. In this line, I have loaded the entire model. Before I continue writing the code, I want to see its summary. Let's run the lines. Initially, when you run this line, it will take a time to load the model. And after I have printed the summary, as you can see here in my IPython console, there is the complete structure of VGG16 model, and each layer is named properly. So we can see here block 1, convolution 1, block 1, convolution 2. So block 1 has 2 convolutional layers. And similarly, if we keep scrolling down, we can see that there are total block 5, and in the last block, which is block 5, has 3 convolution layers. From this model, we are going to crop it. First, we are going to specify the name of layer until which we are going to crop the model starting from top. So here I have used third convolution layer from block 4. Okay, so now I am using Keras model to crop it. So as an input, I am going to take the model input, and as an output, I am going to take the output of which layer I have specified here. I'm going to pass my layer name, and I'm going to say that extract its output. Okay, now I am going to assign this cropped model to another variable, and again I'm going to print its summary. Let's run these lines. As you can see in my console that starting from top, if you notice that the layer input has dimension 224 by 224 and in RGB format, and as you can see the last layer is the same as we specified here under layer underscore name variable. And if you notice that the output of this layer is number of filters 512, and each filter have resolution 28 by 28. Now to predict the features from block 4 underscore convolution 3 layer, I have used image of cat as an input, and to read this image I have used image.io library image.io.imread. As I told you before that the input of VGG16 model is 224 by 224. So I am going to resize it using CV2. And to verify that I have loaded the correct image that I want to, I am going to plot this image here. Let's run these lines. Okay, so my image is displayed in plots window. As you can see, it's a pretty nice image, and when we will visualize the filters, you will see the extracted features around the front object. Another important point that I want to mention that as you notice here in the input shape of VGG16, the complete shape is none, which always represent the sample size, and it is a four-dimensional input. So our image is basically a three-dimensional input, and to convert it as a four-dimension, we are going to expand its axis. So here I am going to use np.expand underscore dims function of numpy, and here I am saying that take the image, which is three-dimensional image, and add another axis at 0. For example, if you see here in my variable explorer window, the shapes are indexed as 0, 1, and 2. So if I say here that add another extension at dimension 0, so it will add 0 in the beginning and will shift the other dimensions towards right. So let's run this line. And now you can see in my variable explorer that the output image, which is cat image, has 4 dimensions, and it has added one another dimension in the beginning of the rest of the dimension. Now we have prepared the input, and it is in perfect shape. According to our pre-trained model, we are going to use our cropped model to predict our features for cat image. I am taking model cropped predict function passing cat image. So this cropped model will return number of filters, and to carry those number of filters, I've created features variable. Now I want to print the information inside features. So for our cat input image, the returned number of feature is as shown in my console. Because we passed one input, so it has the same output size or sample size. So the total number of features, or I call them feature maps or filters or filter maps. So the last index of shape represent the total number of filters, and each filter is sized as 28 by 28. And to visualize these feature maps or filters, we are going to use our matplot library. So first I have written a code in which I have used random library, and here I am saying that create a range from 0 to the shape of features -1. So if I print only this section, you will see that we have got 511 last shape. And as you know, in Python, indexing always starts from 0. So if we have total number of filters 512, so for proper indexing, so that we do not have out of index error, we have to index -1 here to create a range, and I am going to pick randomly 10 filters from this range. Then I have created a loop that will iterate through my selected number of filters, and here I have created 2 by 5 grid so that it will print for me 10 images. And to create a subplot, here I am creating a grid. The first parameter represents the number of rows, and the second one represents the number of columns. So this is going to control the grid number or position as iterated by for loop. As you notice here, I have used 4 indices to point to what filter I am going to print. There is only one output sample, so I am going to index it as 0. For all filters, I am choosing all number of heights or all number of widths, and through iteration of for loop, I am controlling the number of filter that I am going to choose for plotting. And out of loop, finally, I am going to print the final plot. Now we have completed writing the code. Let's run it and see our output filters. So the randomly selected 10 filters out of 512 filters are displayed in my plot window. As you can see here, mostly we can see highlighted regions around cat, and it is so beautiful to see the extracted features that we obtained from a pre-trained model. This is it for this video. Thank you for watching. I hope you find it helpful. If you did, do like and share. Also subscribe the channel and hit the bell icon so that you get notified whenever I upload a new video. If you have any suggestions, leave them in comments section. I will do consider it. Thank you.